To continue our review for your semester final, we're going to solve the absolute value inequality and plot your solution on the number line. So if you remember, in order for us to solve absolute value, the absolute value has to be isolated, which it is. So once it's isolated, we're going to separate it into two equations where x plus 7 is greater than 2, where it's exactly the way the original one is, and then where this is my positive, and then my negative one is where everything changes as far as the inequality sign. So now it's facing the other direction, and now we have a negative value. So it's opposite sign and opposite symbol. And then we just solve for x. So we have plus 7, x is greater than 9. And in this side we have x is less than positive 5. So when we draw our number line, we have one at 5 and we have one at 9. Because there's no equal sign, then we have an open circle, and if x is greater than 9, then we're going to shade the side where it's greater. X is less than 5, so we shade the side that's less than. The inequality notation is basically taking it from here. So we've got x is less than 5 or x is greater than 9. So remember, when we have a disjunction where they're facing away from each other, we use the word or. If they're facing towards each other like this, then we use the word and in between. Okay, so for number 11, we've got what is one point that is part of the solution. So remember, the shaded region is part of my solution set. So anything in this shaded region will be a solution. Anything that is in the non-shaded region is not a solution. So this is my non-solution part. And because the line is dashed, anything on a line that is dashed is not a solution. So if we want to use a point on a solution, I'm going to use this point right here, which is at -10, -5. And if we want a point that is not a solution, then I'm going to choose something from over here. And over here, we've got +1, -7. How did we know the point was in the solution set? Because it was located in the shaded region. How do we know that point 1, -7 is not a solution? Because it's located in the non-shaded region. Okay, for number 12, we're going to calculate f of -2. So notice how if I bring it down over here, that -2 is substituting that x value. So in the equation, we're also going to have it substitute the x value. And that's how you evaluate. We've got 2 times 3 to the second power using PEMDAS. We're going to first square that 3. So 2, and that's going to turn into 9 because 3 times 3 is 9. So 3 squared is equal to 3 times 3, which is equal to 9. So we've got 18 plus 3. So f of -2 is equal to 21. Same thing for this next one. We have f of 8. So f, and instead of x, we're plugging in that 8. So anywhere we see an x, we're going to plug in 8. And then we simplify. 9 times 8 is 72. Minus 5 is going to give us 67. So f of 8 is 67. For the next one, we're going to transform. Now remember, anything on the outside of the parentheses will be a vertical change. So this is going to be a vertical change, and this is a vertical change. Anything inside the parentheses with the x will be a horizontal change. So for that 1/2, because your a value, that's going to be your a, is, and we also want to look at a times x minus h squared plus k. And these are vertical, and this is horizontal. So for your A will tell us how wide or narrow, or if it's stretched or compressed. We know it's a vertical change, so we're going to say it's a vertical compression because your A value is less than 1. This one here, we have a horizontal change, which means it's going left and right. Remember that x lies, so your h is really -9, which means it goes left 9 units. This one is a vertical change, which means my k is equal to -1, and that means we are going down 1 unit. Okay, let's go to the next one. The next one, even with the absolute value, we can still use this, where our vertical change is anything on the outside, and our horizontal change is anything on the side of that absolute value. Notice how this one has a negative. Because it's negative, that means it's a reflection because it flipped. Across the x-axis. If you remember, this one was positive, so there was no change. It's still facing upward. This one, because it's negative, it flipped, so it's reflecting across the x-axis. And then we have 2. It's a vertical change, and because it's greater than 1, then we have a vertical stretch. So this 2, we know it's vertical, and because it's greater than 1, then we have a vertical stretch, because A is greater than 1. For this 3, we know it's horizontal, so that means it's a horizontal shift. And because it is inside with the x, we know x lies, which means my h is actually a positive 3, and that tells us that we're going right 3 units. Here's my k. K is equal to positive 8. We know it's a vertical change, so it's going to go up or down. So because it's positive, that means we're going up 8 units. Okay, we're going to describe this transformation. So when we're looking at the transformation, whether it's going up, down, left, or right, we want to go from the vertex of my original function, which is this parent function, the red one. And it's basically telling, the transformation is for us to say what is happening to my graph to get to this blue, to transform to this blue graph. So if we're going from this vertex to this vertex, that means we're going right 3 units. And then we're going up 1, 2, 3, 4 units. And then we want to notice that the blue one is a little bit more narrow, which means that we stretched it. So if to find our A value, you want to look at the closest point. This one's going up 1 to the right one. This one, if we're going from this point to this point, we're going to go up 3 over 1. So for this one, your A is now equal to 3, which means It's greater than 1, so we have a vertical stretch. Our graphing calculator on Desmos, it says to get the regression equation for this set of points. So we're going to plot these set of points down in our calculator. Now, in order for us to be able to do that, we need to go to the plus sign and we're going to add a table. And then all we have to do now is plug in our points. So we've got 0, 1, 1, 0, and 2, 3. So 0, 1, oopsie, 0, 1, 1, 0, and 2, 3. Then we're going to just click where it says 2, and we're going to use this equation formula for it to give us the equation. So we've got y1, and then that little squiggly that you have to put shift, and it's above the tab key, and then ax1, and then shift 6 squared plus bx1 plus c. And it gives us our a value, our b value, and our c value. So all we're going to do is use those a, b, and c values to write our equation. So a is 2, b is -3, c is 1. So my a is 2, my b is -3, and my c is 1. So we're going to write our equation f of x, or y, is equal to, remember standard is ax squared plus bx plus c. So your a is going to be 2, your b is -3, and your c is going to be 1. So 2x squared plus, sorry, let's do minus, because it's a negative, 3x, and then plus 1. And the same thing for the y.